Hi, this is Alex from devstories.eu. Learning DSPy, episode 11 of 15. Prompting massive models is great for getting a prototype off the ground, but when that logic hits production, the latency and cost of a 70 billion parameter model quickly become a problem. You need the reasoning power of the large model, but the speed and price of an 8 billion parameter model. That is exactly what BootstrapFinetune handles. BootstrapFinetune compiles your DSPy program into a fine-tuned model. It serves as the ultimate optimization for efficiency. It updates the actual weights of a smaller target model to mimic the exact behavior of your heavy pipeline. A common misconception is that to fine-tune a model, you have to manually gather thousands of examples, format them into tedious JSNL files, and babysit a training loop. BootstrapFinetune completely automates this. It handles dataset generation, formatting, and the weight updates entirely through the execution traces of your program. Take a concrete scenario involving a banking intent classifier. The program takes a messy customer message and categorizes it. Initially, you build a DSPy module using a highly capable model like GPT-4o Mini, configured to use chain-of-thought reasoning. The model thinks step by step through the customer phrasing before outputting the intent. It gets the right answers, but it is too slow and expensive for real-time chat. To optimize this, you initialize BootstrapFinetune. You give it your evaluation metric to measure success, and you specify the smaller, cheaper target model you want to deploy. Then you compile the program. When you hit compile, DSPy runs your unoptimized program over your training data. It uses the heavy teacher model to generate outputs. The teacher model watches this execution. Every time the teacher model gets the right answer according to your metric, BootstrapFinetune captures the trace. It records the inputs, the step-by-step reasoning, and the final output. It maps the internal logic of the massive model into a format the small target model can ingest. Once enough successful traces are collected, BootstrapFinetune automatically structures them into a training dataset. It then triggers the fine-tuning process on your target model. The small model is trained directly on the high-quality reasoning paths generated by the large model. Here is the key insight. The smaller model learns the specific task distribution and the reasoning style required to solve it without running the heavy chain of thought at inference time. In our banking classifier example, a standard small model might only achieve 66% accuracy out of the box, but after compiling with BootstrapFinetune, that same small model jumps to 87% accuracy. Fine-tuning is no longer a separate infrastructure project. It is simply another compilation step that turns an expensive reasoning pipeline into a fast, cheap production asset. Thanks for listening. Happy coding, everyone.